All right, welcome back. Happy Wednesday. Today we are covering something called complex numbers and quadratic equations. Today, quiz number 1 is due, so throw it in the green folder. If you don't have it, I don't have a makeup policy, or I should say the makeup policy is you get a 0 on it. It's like if you don't show up on the day of a test or a quiz, it is a 0. So I'm really hoping all of those quizzes are in the folders. But if you don't have that quiz done, talk to me like right after class today. I don't know that I can do anything for you, but throw them in there if you have it, even if it's not done. Coming up over the next couple of classes, on Friday, we've got one more day of new material. Monday coming up is our review day for the first test. I have no other agenda on that day other than to review. And then our very first test is a week from today, Wednesday next week. It is on lessons or classes 1 through 8. That is to say everything that we are doing up through today and Friday. So after Friday's class, that's the end of the material for the test. Monday is our review day, and then Wednesday is the test, okay? Best way to prepare for the test is to do all the My Math Lab homework. And I think that there might be like some sample test problems later on in the packet. We'll talk about them coming up, okay? Any questions on the calendar? Okay, so project 1 was due last class. I graded it. I just gave back all the projects that I got. I just want to say this. I would encourage you to not just look at your final score on the top right of that page and then throw the project away, never to think about it again. I would encourage you to actually look at the things that I circled on the rubric there. And look at the comments that I made near your writing on the, when you answered those 5 or 6 questions in words. Like I wrote some things and I circled some things, and the point here is not the grade, the point is the feedback. And I don't want you to lose points on the test for exactly the same things you might have lost points for on this project, okay? So later on, you're gonna take a look at the stuff that I wrote, stuff that I circled. If you're not sure why I circled things or why you lost points, ask me, I'll tell you, okay? But I don't want you to lose points again. All right, so taking a look here, we'll jump into the teaching demo here, starting with number 1. Okay, so brand new for today, but you might have seen in a previous math class, complex numbers. So here's our first definition, is the square root of a negative number. The letter I is the symbol we use to note the square root of -1. All right, so the letter I is the symbol that we use to denote the square root of -1. So instead of the square root of -1 and calling it not a real number or doesn't exist, which maybe we did until this moment right here, we're just going to say, hey, why not just play with the square root of -1 instead of stopping the problem anytime we get to that kind of a thing. And we're just going to call that number I. It is not so unusual for mathematicians to change famous numbers into letters. Can anybody name a famous number that we know of better as a letter? Pi, right? Everybody here has no problem thinking, oh, pi is just this 3.1415, right? It just goes forever, and it's okay that we just call it pi. Some of you might know the number e. Yeah, and so e is around 2.7, and it goes forever as well. And so it's something that we do. Famous numbers, we just change them into a letter. It's a little bit unfortunate. I think was historically chosen for the word imaginary, but that makes it seem like the square root of -1 is somehow like less legitimate than all the numbers that we're comfortable with and familiar with, and that's just not the case. It's a full-fledged number. It is no less legitimate than the number 7 or -42. I mean, it just is a number. So don't think that because we call them the imaginaries, somehow they're beneath, they're under, other numbers. They're legit. Okay, so here's the technique that we'll use. If k is a positive real number, then anytime you see the square root of negative anything, you're just gonna factor that into -1 times the positive version of that number, and then square root of -1 we said is I. And so I comes outside, the number inside becomes positive. So let's try it here on number 2. Looking for the square root of -49. We're going to rewrite that as square root of -1 times square root of 49. We buy that. And then instead of square root of -1, what are we putting? I. And then square root of 49 happens to be a nice number, 7. So I, 7 is okay. Typically, If it's a rational number, then you stick it in the front and you put the I at the end. But we'll see in this next case, the I will stay in the front. Okay. Same idea here for square root of -8. This equals square root of what? Let's first leave it that way, -1, and then before we get to 4 times 2, what am I putting here? 8, right? It's just pull the negative off to the side. That's all. No, nothing fancy. And then the square root of -1 we now know is I, so that's just the definition. And then, yeah, the square root of 8, 2 root 2 is skipping a step in there, but I think we're good at that at this point. And so that's okay, but again, if you've got a rational number, typically you put the I after, and so maybe like that. I'm going to write the word or here. Totally okay, like if you do something like this, 2 root 2I, I mean, that's okay. It's just multiplication, so it doesn't matter the order in which you write it, but you are never going to see me write it that way. Do you know the danger with writing it that way? Yeah, if you are just a tiny bit sloppy with that radical sign, all of a sudden the I looks like it's underneath. And that is definitely not the right answer. So it's okay as long as it's clear the I is not in the radical, which is why maybe it's safer to just put the I in the front. No confusion about that radical. So, okay. All right, let's see. And then finally, part C here, I squared. Okay, let's try this. I squared. Let's see. Let's write it like this. I times I. Right? That's I squared. I times itself. And then I is the square root of -1 times another I, which is another square root of -1. And what is that? Is it +1? No, it's negative. Yeah, like if I gave you this, like square root of 5 times square root of 5, what is that? Isn't that just 5? Right? Because the square root times itself, the radical just disappears and you get whatever the number is inside that radical, right? So what's the square root of -1 times the square root of -1? It's -1. It's not 1, it's -1. So the fact that we need, our big conclusion here is that I squared is -1. Okay, let's try number 3. Number 3 talks about the square root of -20 times the square root of -5. So let's do this in the way that you might have done if you took Math 096 here last semester, or maybe some previous algebra class. I'm going to write down a property here, square root of maybe x times y equals square root x times square root of y. Does that look familiar? It might be different, maybe a and b instead of x and y, but this is a fundamental thing that we played with a bunch in Math 096 or some previous algebra class for you. And so if I use this property, it tells me that if I have one radical with multiplication inside, I can split it into 2 radicals. But then just go in the other direction, if I have 2 radicals multiplied, I can smush together into a single radical, right? And so that's what I have over here. So I'm going to say don't write what I'm about to write. But I'm going to try to apply that property here. Don't write this. This is now taking 2 radicals, smushing to a single one. So according to that property over there, it's just the square root of -20 times -5, right? Okay, and then square root of, let's see, just multiplying those two, we get 100, yeah? Okay, good, and the square root of 100 is 10, just plain 10. Some people say like plus or minus. It's not. That radical symbol always means the positive square root. Okay, so here's the problem. The problem is that's not the right answer, and I'm going to show you what the right answer is, and then I'll show you where we went wrong. Do write this thing down. Square root of -20. We are every time now going to do that as square root of -1 times square root of 20. Fair? Times, and then we'll play the same game with the other guy. So what 2 radicals for that? -1 and 5, right? That's our technique now. See a negative in that radical, just pull the -1 off. Okay, let's go ahead and do these 2 guys here. When you multiply those 2 together, what do you get? We get -1. That's the thing we just saw. So those 2 together definitely -1. And then these two together, I'm going to use our property that says, hey, we can just multiply the two numbers. That's what we tried to do before, although somehow something went wrong. And so this is equal to -1 in the front, square root of what number? Square root of 100, which is a -1 in the front times 10, right? Square root of 100 is 10. And so this answer is -10, which is really troubling to me because I felt like we did okay work before and we got +10 and now we got -10 and the answer can't be two different things, right? So one of them is wrong, and I mentioned the spoiler is that that first thing is wrong. So here's where the first thing went wrong. Second thing is right. -10 is the correct answer. Here's where we went wrong. Remember, like your algebra teacher told you that this was true, right? Well, that was a lie. And for some of you, I know that I'm breaking your heart because I was the person that told you that this was true. So I apologize, but I didn't give you the full truth when I taught 096 last semester. What's that? I did, and you have no reason to believe anything else that I say, including that that is a lie, that equation right there. So that equation right there is true, provided x and y are what kinds of numbers? All positives. If that has only positive x's and y's in it, then it is absolutely valid, that equation. And if you took some intermediate algebra class somewhere, you were using that equation with only positive numbers and the teacher didn't bother to say, hey, this is only valid for positive numbers. But if x or y is negative, you have to do this thing where you pull that square root of -1 off to the side, okay? So I'll just make a note here. Only for x and y positive. And I think that's basically what number 3 says. If a radicand is negative, that's the x or the y. If a radicand is negative, we write the radical in terms of I before performing any operations. So pull that square root of -1 off to the front. That circled purple thing is I. One positive and one negative. Good question. Want to make up an example, Liam? Do you want to make up an Okay. Okay. All right. So if we try it the potentially dangerous way, what do we get in here when we push them together under one roof? Square root of -18, and then we see that negative, and then we play our game. Always got to do this, right? -1, positive 18. So that becomes I root 18. Okay, so maybe, I mean, we tried the thing, which is sometimes a lie. You could clean up the root 18 because 9 goes into it, but we're not going to do that right now. The way that for sure works is to break this -6 up into a -1 and a 6. Yep, and then the other guy is copying the root 3. Okay, this square root of -1, what is that also known as? That is definitely I, right? Square root of -1 is I, so definition. And then the thing that's a lie is absolutely true as long as the numbers are all positive. So 6 and 3, we definitely can push together with no problems at all. We get that. So this is equal to I square root of 18. So what happened? Did it work? Yeah, doing it the potentially dangerous way here in black gave us I radical 18, which is definitely the right answer in green. So we're okay. It's one positive and one negative. So why chance it? I just figure any negatives I see, I'm bringing I's into the picture instead of taking the risk. Good question. You should go farther than we did, right? Yeah, 3I radical 2, I think is. Okay, next page. All right, on the next page, we introduce a fairly big topic. Let's give this a shot. So we're introducing quadratic equations first by comparing them, contrasting them maybe, with linear equations. Linear equations are first degree equations such as 2x plus 1 equals 5 and 4 minus 3x equals 2. When we say first degree, where's the 1 that we were talking about in the word first? It's above the x, right? That's really 2x to the first degree. 4 minus 3x to the first degree. Don't have to write it, but that's the first we're talking about. But quadratic equations are second degree equations. So we are going to see above the x a 2. So 2x squared, that squared right there is the second that we are talking about. Plus 3 equals 5x. Negative 2x minus 7 squared, that squared right there is what makes this a quadratic. They also have x to the first terms in them, but we're really just talking about the highest power we see. Okay, just some vocabulary. The general quadratic equation has this form: ax squared plus bx plus c equals 0. That 0 is going to be key for us. A, b, and c are real numbers, and a is not 0, because if you made a equal to 0, then this term right here becomes nothing, and all of a sudden it isn't quadratic anymore, right? That's the only reason that's there. We are already familiar with techniques used to solve linear equations. We now look at some ways to solve quadratic equations. Let's take a look at this equation right here, and then we'll talk about the thing that's written up above. X squared equals negative 25. Let's give this a shot. Okay, what should we do to both sides to solve square root, right? Not square, but square root of both sides. So I'm going to copy that equation again, and then in a different color, I'm going to put that square root in front of both sides. So that seems legitimate. I did the same thing to both sides, taking the square root. Okay, on the left-hand side, that's really nice, right? What do you get on the left-hand side? X, right? That was sort of the point, was to eliminate the square, and we do that by square rooting. And on the right-hand side, well, let's see, square root of negative 25, that's our new technique here. So that's really square root of what times square root of what? Negative 1 times square root of 25. Square root of negative 1 we have seen, that is also known as I. And then square root of 5 happens to be nice. It's just plain 5. So 5i. Okay, so that's fine. That's our solution, 5i. And I also just want to point out that it's totally okay with me if you skip the step that I just put that little arrow over. I actually don't need to see the negative 1 in the front. With a little bit of practice, you start to recognize, oh, a negative in the square root just results in an I, and then it becomes the positive. That's all. And it's okay with me if you just go to that answer. But until you're really comfortable with that, keep writing that negative 1. Okay, so that's okay there. Let's just try one other. I want to try here. Okay, it turns out there's another answer. 5i is definitely a solution to that first equation, but it's not the only solution to that first equation. Anybody know what the other solution is? Factor? What do you want to factor? Say it again. X squared.
X squared minus 25.
So yeah, so if we bring the 25 over, well, I like 0 in some equations, so I like the idea of moving the 25 over. But when you move it over, it doesn't stay minus 25 anymore, right? It becomes plus 25. And that guy doesn't actually factor the x squared plus 25. Yeah, yeah, yeah.
Oh, you just equal 0, so you just add side.
Well, yeah, I think that's what Jamie was suggesting. This thing here, but that guy doesn't. I mean, it doesn't factor, right? Because it's now a plus in the middle. Yeah. But there is another solution to this equation. Let me give you one with not i's in it. If I just said I'm thinking of a number and I square it and I get 16, what's the answer? 4. What's the other answer? Negative 4, right? Because if you take negative 4 and you square it, it becomes positive 16, yes? So there's this kind of funny plus or minus. It's really easy to just do the plus and say, hey, x equals 4, we're done, but we missed one. And so what do you think is the other answer? Not just 5i, but also negative 5i. So I'm going to put in this plus or minus right there. Really, really easy to miss that. So here's the biggest hint that I can give. And I say this knowing full well some of us are still going to forget it. It's I don't know, like I can sing and dance, but this just it's so easy to forget this. But looking at the original equation, this number right up here tells you how many solutions. That highest power up there tells you how many solutions the equation has. This is a universal truth. And you can trust me, even though I might have lied to you last semester. The power, the highest power, is the number of solutions. So perhaps the first thing to do when solving a brand new equation is to just make a little note. Whatever that highest power is, that's how many solutions I expect. So coming up to this guy, how many solutions? 1. You're not going to be surprised when you get only 1 solution. This guy, how many solutions? 2. This guy, how many solutions? 2. X to the 5th minus 2x cubed plus 7x squared plus 4 equals 0. 5 solutions. I have no idea how to find those 5 solutions, but I know for sure there are 5 of them, if only I had a method to get them, right? So it's really easy to forget the plus or minus, but perhaps if you look at that equation the first time you see it and just say 2 solutions are coming, and at the end of the problem, if you only have 1, it means there's something that you missed. Okay, so I think we've got our answer there. So then in general, if you are looking at something like this, let's actually go back to this one first. Ax squared equals c. So that kind of looks like this equation up here, except there's no b term. So perhaps b is equal to 0, which is why it wouldn't appear. Okay, so in that case, I would move that a to the other side. So x squared equals, how do you move the a over? Divide, right? So c divide by a, just divide both sides by a. And then what's our technique? What do you do to that equation is the square root. And so we put in that square root there. And we don't forget that we need to also include the plus or minus. 2 solutions. And in fact, that would be the technique I would use on, on this equation over here. Whoopsies. Let's try that again. That equation right there. First, I would move the -2 to the other side by dividing. X minus 7 squared equals 10. And then do what to both sides? Take the square root. And when you do that, the squared on the left-hand side disappears. And the square root moves over there. It might be easy to forget, but what did I forget? Plus or minus. Add 7 and it's done. So anytime I've got just like a lot of stuff squared equaling a number, this is the magic technique, but know ahead of time. 2 solutions. You're not, honestly, most of us are not going to remember put in plus or minus, but I'm hoping that we remember 2 solutions. Look at that power. That's how many we expect to see. Okay, moving on. Next technique, we've got something called the zero product property. We'll come back to it. Let's jump into 7. So solve the following quadratic equations by factoring, and we'll list our solutions using the roster method. Let's give this a shot. Okay, first thing I'm going to do is make 0 on one side. It will be clear in just a minute why 0 is a good number to have over there. So I'm going to add 24 to both sides, leaving 0 on the right. Okay, the left-hand side factors. It's still equal to 0. Don't lose that. So the left-hand side will factor. Some of us will use a 2x2 box. Some of us will do trial and error. Some of us are just really good at factoring this kind of thing. I'm just going to put the answer up here, but know that you can take your time to factor it. Anybody want to share the answer? What is this? I'll say +3 is good. Don't worry about it if it takes you longer than that to get it. Take your time. Just make sure you can get there. Okay, so here's a fact. This thing in here is a number, And it looks complicated because it's two terms, but that's okay. X plus 8, I'm just thinking of as a single number. Inside parentheses, it's a single number. X plus 3 in the parentheses is just a single number. Forget about the fact that there's complications inside here, but just I've got two numbers multiplied together, and I get 0. What's the only way that I can multiply two numbers and get 0? Is if one of them is 0. That's the key. So for sure, either the green thing is 0 or the yellow thing is 0. And that's two simpler equations than anything I've got written up here. And I'm going to write them. Either x plus 8 is 0, that's a one number equals 0, or x plus 3 is 0, that's the other number equals 0. Multiply and get 0, one of them had to be 0. This is why we forced the number 0 on the right-hand side, is that moment right there. Because if we decided it wasn't 36, like let's suppose that, we had the number 30 over here. Instead of a 0, we had 30. If you multiply two numbers and get 30, does one of them have to be 30? What could they be? Two numbers that multiplied 30? 5 times 6, neither of which is 30. 15 times 2, neither of which is 30. There's nothing special about 30. There's nothing special about any of the numbers except for the one that we are after, which is that 0. It's the only one that we get more information about. When you multiply two things and get 0, we know for sure that one of them is 0. Okay, and then these equations are straightforward to solve. Subtract 8, subtract 3. We've got our answers. How many solutions did we get? 2. Should we have expected 2? Yes. 2 solutions. Okay, so that is one way to solve that equation right there. There's another technique. We're going to stay right here and do it on this page. Don't look on the next page just yet. But there's another technique to solve quadratic equations, and it's this thing called the quadratic formula. So I'm just going to write the ax squared plus bx plus c equals 0 here. How many of you think you remember the entire quadratic formula? It's just in your brain right now. That's okay, and then some people kind of wishy-washy. All right, some people are like hearing a song in their heads as they go through it here. All right, so negative b plus, so go ahead and copy this thing. B squared, it's 4ac, all divided by 2a. So write all of that stuff down. Hopefully we've got it in our brains, at least partially. Okay, I think that that is incomplete. There's nothing wrong in there, but I would really like to have a name for what I have found with this crazy formula. It's x. This is what we found. We have found x. We have found the solutions to an equation. So when we are solving this equation right here, with that crazy formula, what we are about to get out is x equals negative 8 and x equals negative 3. It's not just like this isolated thing. It's x equals. So put the x equals. Okay, so let's give this a shot. For that equation right here, is it currently in this form right here? No. So the 0 is part of the quadratic formula, which means instead of using the original, we would still need to go down to the second equation. That's the one that we're going to use the quadratic formula on. And so according to that equation, we should be able to read off the values of a, b, and c. A is always the number touching x squared. It is 1. B is always the number touching x. It is 11. C is always the number with no x's. It is 24. If any of those things had subtraction on the left-hand side, we'd have negative numbers for A or B or C. So copy the signs. It turns out they're all positive in this case. Okay, so now it's a matter of carefully plugging into our crazy quadratic formula. Negative b, opposite of b is negative 11, plus or minus square root of b squared, 11 squared, minus 4 times a times c, 1 times 24, divided by 2 times a, 2 times 1. Before we continue this one, can we just pause for a second and pretend that this had been a negative 11 here? Don't write it down, but just pretend for a moment. So if that's a negative 11, then this becomes negative 11 squared, right? B squared. How much is negative 11 squared? Well, yeah, that's the question. It's about parentheses. According to this expression, what is this equal to? It's negative 11. Is it 121? This is negative 121. You guys know. Oops. Come on. This thing is really saying negative 1, the opposite of 11 squared. You know that exponents come before multiplication. So that would say do 11 squared first, get 121, and then take the opposite, which is negative 121. So this guy is negative 121, and if you type it on the calculator, that is exactly what you'll get. If you type negative 11 squared just like that, you're going to get negative 121. But what we really mean is take the number b and square it, the entire number b. And the entire number b in my pretend example is negative 11. And so Matt's absolutely right. According to the quadratic formula, we should have taken the entire negative 11 and squared it. And what is negative 11 in parentheses squared? It is 121. So this isn't just like a semantic thing. And it's not even like a, hey, I'm going to take points off if you don't put parentheses. It's that if you're not paying attention, you are going to write something down and then get the wrong answer because you didn't write the correct thing down, right? This is not semantics. This is, you will get it wrong. You type it in the calculator, you will get it wrong. If you forget the calculator and just do what it says, you will get it wrong. So let's get it right by writing the correct thing. So here's my recommendation. Lots and lots of parentheses. Come back. Okay, so I think this is where we were. My recommendation is this. Anytime there was an A or a B or a C in the quadratic formula, it gets parentheses. Every A, B, and C in the quadratic formula gets parentheses. Oftentimes that's overkill, but I'd rather have some overkill, some extra stuff that I don't need and get it right every time than to be hyper efficient, but occasionally need the parentheses and not have them and get it wrong. Okay, so let's finish this guy up here. Equals. Okay, so negative 11 is there, plus or minus square root of 11 squared, that's still 121, minus 4 times 24, I think that's 96. Yeah, 96. Divided by 2 times 1 is just 2. Negative 11 plus or minus square root of. Okay, so then we just subtract here. 121 minus 96 is 25. Divided by 2. In many problems where you use this quadratic formula, that's the last step right there. We're done. But how come we're not done in this one? Because it's 25, right? If it were 26, we'd be done. Right, square root of 26, we can't do anything with. But occasionally you get something where you can. So we do have to go farther, but normally this is the end. Okay, so this is negative 11 plus or minus square root of 25 is just 5 divided by 2. And I mean, this answer is correct, but it's just written in a very strange form. So typically at this moment, only because the square root of 25 was something nice, we should split this up and either write negative 11 plus 5 over 2 and negative 11 minus 5 over 2. Okay, negative 11 plus 5, that's a negative 6. Divided by 2 is negative 3. And then negative 11 minus 5 is negative 16. Divided by 2 is negative 8. Those are our two answers, which of course agree with the two answers we got before. Okay, so in conclusion, we have seen 3 methods to solving quadratic equations today. This is the quadratic formula. You can use it on any quadratic equation under the sun. It will always work. There is the factoring method, which we did over there in blue, that will work if the thing factors. but if it doesn't factor, it won't work. And so it's kind of a trade-off here because of the two choices that we have for this same problem here, which one seemed more straightforward, shorter? Is blue for sure, right? Like if it factors, it is definitely quicker and probably less prone to error than the quadratic formula. Look at how many opportunities there are to make a mistake in that mess over there. So it is true you could use the quadratic formula on any quadratic equation, but if you have one that factors easily, you're kind of spending a lot more time and energy than you need to. And then finally, there was this other idea of take the square root of both sides. You can really only do that if it just looks like x squared equals a number. That is not very often, but if it is, this is a lot quicker than using the quadratic formula, which we didn't try on this guy. In Math 096 last semester on like tests and quizzes, I forced my students to use different techniques in solving these problems. I would say, use the quadratic formula on this one, and here's a bunch of others. Don't use a quadratic formula on any of them. I'm not going to force this semester. So whatever you want to do is okay. We've seen 3 techniques. If you get good at all 3, you will be able to use the most efficient method possible and probably have less opportunity to make a mistake. But if you want to put all your eggs in that quadratic formula basket, it's okay by me. Just got to do it carefully, all right? Okay, on the next page is the quadratic formula written out. You are going to jump to this class activity right here. Raise the flag if I can help.